That should be good. Okay.
So I saw two groups, I think, that had the right idea on 1A. There might have been more of you that I might not have seen. Who thinks they had the right first step on 1A?
You should just multiply the top and bottom with the square root of x minus 1 plus 1.
Beautiful. So I don't care so much about the name of something. I just want you to know how to do it. But the name of what we're doing, sorry, Mike, you might have to move over.
I can see it right there. Well, I can't.
But I mean, hopefully everybody else is the conjugate. Do you guys remember that word?
Yeah.
So it's what you use when you want to rationalize the numerator or the denominator, and normally it's the denominator that we want to rationalize. Is everybody with me? What do I mean by that? What's an irrational number?
A number that can't be expressed as a fraction.
A number that can't be expressed as a fraction. So most commonly it's radicals. Square root of 2 cannot be expressed as a fraction when you realize a fraction is a ratio of whole numbers. Can't do that with square root of 2. Right? Or pi, for example, is another big one. You with me? So if I want to rationalize the bottom, that means get rid of the radical. So if I multiply by the conjugate, that's like a difference of squares. Remember x plus 1, x minus 1, the middle terms cancel? That would be the only place a radical could exist. If I make them die, no radicals exist. So real quick, what's the square root of 17 times the square root of 17? Freaking 17. Half of 17 times the other half of 17 is freaking 17, yes? That's beautiful. Is everybody with me? What's square root of 17 mean? No, that's 17 squared. What's the square root of 17? Beautiful. So in a sense, it's half of 17 multiplicatively. So when I multiply it by the other half of 17, of course I get a whole 17 all. Okay. So if I multiply this by the same stuff as the bottom, except I make it plus 1. On the top, the trick that I don't blame some of you for not realizing, the trick is don't multiply the top out. Because what's going to happen on the bottom? Well, what's the square root of x minus 1 times the square root of x minus 1? X minus 1. And then the middle terms cancel, yes? Minus this plus this. And then negative 1 times 1 is negative 1. So what do I get on the bottom? And they kill each other, so then my answer is just this. Crazy sauce. Yes? That's the, okay, so let me do another example. Let me make sure, has everybody got this here? Let me make sure. If this had been a minus 1, would the middle terms have canceled? Then there would have still been a radical in it, and we're trying to kill the radical because we're just like that. Yeah, okay. Talking about radicals, we got this dude. So let me show you an example I was showing a few groups. Does anyone remember how to simplify this? And some of you guys I showed this, so just sit on that for a minute.
That's going to be like 2 radical 11.
Yeah, how'd you get there? Go ahead.
You can take the square roots that are smaller than that multiply 244. So, for example, the square root of 4 and the square root of 11.
Yes, 44 is 4 times 11. So this is square root of 4 times square root of 11. Yes? Square root of 4 I know, square root of 11 I don't. Very quick analogy. This is currently you can do it, Jeff, improper fraction. How do I make it into a mixed number? Well, here's one way. What do you wish that was on the top? Don't you wish that 9 was up here?
Not 17.
Huh? Sorry?
Not 17 over 2.
Okay. Don't you wish that 9 was up top? Because that would just be 1, right? So isn't this 9 plus 8 divided by 9? So what's 9 divided by 9? And what's 8 divided by 9? I don't know. So there's another way to get like a mixed number, right? So it's the same idea. I break it up into something that does work, and then the thing that doesn't work, I just leave it. So 9 divided by 9 works, 8 divided by 9, I don't know. Same thing here. So what can I do with this then? The only thing I can do with this, and this is not equal to 2x plus 8, and I'm not picking on anybody, because a few of you guys said this, right? And just to show everybody this, is the square root of 13 equal to 5? Is that true? No, obviously not. But isn't 13 4 plus 9? Isn't the square root of 4 2? Isn't the square root of 9 3? But what are radicals based on? What operation are radicals based on? Multiplication. So they will not play well with addition. You can't distribute a root across addition because they're not based on each other. What's the other way to write the square root of something? To the what power? 1/2 power. And I cannot distribute a power across addition subtraction, correct? If I wanted to know what this was, do I just square each piece? Can I just square the x squared of the 3 and be done with it? Is this right? Hell no, we gotta FOIL it. Why? Because the addition makes things suck. Exponents are based on multiplication, not addition. They don't play well together. So what can I do with this? The same thing we did with 44. Can you factor the inside? Yes. What's the square root of 4? 2. What's the square root of x squared plus 16? I don't frickin' know. Done. Do the part you can, leave the part you can't. Okay, maybe. So you cannot distribute a radical across addition or subtraction. This will happen in this class and in Calc 2, yes.
Could you factor that and then root it?
It won't factor.
No.
Nope. I can only factor with complex numbers, but even then, they're two different numbers, so I can't take the square root of it. It'd have to be two of the same thing for me to square root it. Okay, maybe. Yes?
So with that one, we can look at it as like the square root of 4 and then what multiply like as two separate things, like we're splitting this.
Yeah, multiply by some other number.
Yeah.
And I don't even know what the number is, so I can't do the square root of it.
Okay.
Yeah, okay. All right. So what about logs? Do you guys remember the properties of logarithms?
I remember that a common log is a log base 10.
Good. So these are all log base 10. That could become important here in a bit.
Minus is division.
Minus is division,
Plus is multiplication.
plus multiplication. Real quick, what is a log? It's this thing, it's a tree. No.
It's an inside out exponent.
Yes, so a log is an exponent. So let me ask you real quick. Let me ask you a couple very specific questions. What is log base 2 of 8? 3, because the answer to a log is always the power I need. A logarithm is a power, yes?
Yep.
So the properties of logarithms are the exact same properties of powers. When do I subtract powers? When I'm doing what with two things? Dividing. When do I add powers? Multiplying like bases, right? So look back at this. Logs are powers. This here says I'm subtracting these two powers. What must I have been doing with the stuff?
Not divided.
Dividing them. So all I did there was make it seem like you need glasses. Okay, all I did there was this is minus this log. The difference of two logs becomes the log of the quotient. Why is that true? Because the properties of logarithms are the same as the properties of powers. Okay. Okay. I like it. So again, just to let you guys know, I don't want to, this is not meant to freak you out. I'm trying to point out the things you might need to go back and review. Some of this stuff we are going to cover as it comes up. You guys all with me? So I'll do a quick little review about this stuff as it comes up this semester. But a lot of this stuff we have to kind of know. It's going to come up whenever it needs to come up. So right now I'm trying to give you an idea of the kind of things you need to review. A big one is factoring, right? Factoring is everywhere. You have to be able to factor. It's like the bread and butter of higher level mathematics. Factoring is wherever the hell it wants to be. It's everywhere. Logs are not going to come up too often, but we just have to remember how they kind of work. So now I've got two logs and they're adding. When do I add powers?
You're multiplying.
When I was multiplying. So now I can rewrite this as notice this, there's a shortcut here. What's the only log that's negative? It's the only log that I'm subtracting. notice how it's the only thing on the bottom. So if it's a minus a log, that ends up on the bottom. If everything else is positive, it ends up on the top because they're all multiplying and not dividing. So there's a shortcut there, yes? Now what can I do? I'm not done with this. I have an expression inside, and I want to do the opposite of multiply. Because I have a fraction here, right? So what's the way I could do some more simplification is if something cancels. So I want to factor everything. So what can I do here? Take out on the top, I can take out a 10. And what can I do on the bottom? Take out an x. And then inside this log, I could just do normal cancellation. So of course an x cancels. X minus 1's cancel. And what's log of 10? 1. Because it's asking you, like Michael said, the common logarithm, we don't write a 10 because it's the most commonly used logarithm. Do you guys know why 10 is the most commonly used base for a logarithm? Because we have 10 fingers. That's the same answer to the next question, which is why do we have a base 10 number system? Because of these. So what's the most common way to count stuff on your freaking fingers? So that's why we have a base 10. If we had 12 fingers, we would have a base 12 number system. Don't worry, I'm not going to suddenly try to teach you base 12, right? Some of you guys know base 16. Anybody do any computer programming or anything? Base 16. Yes, of course, base 2 is the one everybody thinks affects binary, but then you got hexadecimal for base 16. It's how you tell a computer what color you want your background to be on a web page. Okay, enough of that. Okay. So this question is, what power does 10 need on it to become 10? Well, of course, power. So the next big thing we got to remember is how to factor stuff. I saw a few right answers for this guy. I saw a few that went further than I really thought you would go, which is awesome. How many terms are there in this problem?
2.
2 terms, because what are terms separated by?
Minus.
Minus and plus. So this one's got 2 terms. So what could it be? Either squares or cubes. This one I can cut everything in half, so it's a squares. When you have a difference of squares, you say thank whatever your favorite deity is, right? God of coffee, God of math, whatever. Because it's going to be easy as hell. If it's a difference of squares, it must be easy, because you just cut everything in half. So what's multiplicatively, right? So what's half of 81 multiplicatively? Crazy. And then a to the 4th? So if I put one over there, I just made 81 a to the 4th, yes? Same thing with 16w4, so it'll be 4w squared, 4w squared. And if I put plus minus, that's what makes me have no middle term. Now am I done?
No.
Because this one is a difference of squares again, right? So I'm not going to go as far as one group did yet. I will in the next step, but can't I go further with this one?
Yes.
Same way, right? So it'll be 3a minus 2w,
Plus or minus.
3a plus 2w, right? Yeah, love you guys. So let me show you a little example of why we can do one more step, believe it or not. So where you got that? So if I said factor this using real numbers, this is where we would stop. So let me ask you kind of a related, easier question. How do I factor this? Yeah, x minus 7, x plus 7, right? So why does that work? Because since it's a negative, I'm allowed to have different signs. I need different signs so the middle terms cancel. So why can I not factor this using real numbers? In order to be positive 49, they would have to have,
They'd have to both be positive,
they'd have to both be the same sign,
which means
plus
that
or
you
minus.
can't
So the middle
get rid
term
of the
would
stuff in the
never
middle.
cancel. So if you thought it was x plus 7, can't be, because I don't have a 14x in the middle, right? If it was minus, can't be, because I don't have a negative 14x in the middle. But, one group, little tears for you, my one little group that I saw, maybe there's more. You can go further with this. Does anyone know how to factor that? You have to use something that's not real.
It's the same thing, you just put an I on the second term of each.
Yeah, just put I, yeah, there, Jeff. Just put i's in there. X plus 7i, x minus 7i. What's I again? Do you guys remember what I is? What do I be?
Square root of negative
I do be
one.
square root of negative 1.
Square root of negative 1.
Imaginary is a bad name. When we first thought of negative numbers, there was a whole group of people that called them imaginary, but nowadays we all know way too well the bank sees them as very real. Yes, for example. When we came up with the square root of negative 1, we called it imaginary a bad name. They're not imaginary. They exist. If you're going to go into any electromagnetic stuff, if you're going to be in electrical engineering, the funny thing about electrical engineering, engineers use J instead of I just to be different, right? But it's the same idea, it's an imaginary number. But you can't describe voltage fields without imaginary numbers. They are used in physical, real world situations. So they are not made up shit. It's just a bad name. You guys at all with me? How comfortable does anybody feel does anybody feel really comfortable about complex numbers? Normally not so much, because you normally don't use them that much. I don't blame you. But a quick thing about imaginary numbers, since we're talking about them. And then I'm going to give us a break here in a minute. If I multiply by a negative 1, so if I take 1 and I multiply by negative 1, don't I rotate to the other side? So if I multiply any positive number by negative 1, it just rotates to the other side, correct? And if I multiply negative 1 by negative 1, I'm going to do the same thing. I'm going to rotate so I get back to 1. You guys all with me so far?
Yeah.
But you don't often think of multiplying by a negative 1 as a rotation, but that is what it is. So how would I stop at the y-axis? I wouldn't multiply by a whole negative 1. I would multiply by half of a negative 1, yes? Let me try this again. So instead of going if I multiply by a full negative 1, I rotate all the way to here, yes?
Yes.
What if I want to stop there? I'll have to multiply by negative 1 to the 1/2 power. The square root of negative 1. Half of a negative 1. I want to turn half of the way, yes? You guys that all with me? Now I understand by itself that doesn't immediately make mathematical sense, but visually, does that make sense?
Yes.
If a whole negative 1 makes me go all the way, half of a negative 1 will make me go halfway. So this would be square root of negative 1, which we call I. So that axis would be the complex axis. And this is not something you guys get exposed to too often, and it's actually not something that's going to come up very often for us in this class. But I just want to make sure you guys remember what complex numbers are. They exist. If you go much further in mathematics, you're going to do a lot more with them. Okay, maybe. Okay, enough of that. So this one, I could do this. 3a plus 2wi, 3a minus 2wi. But if you got to here, I'm a happy person. If you got to here, I'm actually like, holy shit, that's amazing. Yes?
How come you would do just wi and not ai as well?
Oh! So I could turn this around and I could put the I on the 3a instead, but that's equivalent to like factoring an I out, just moving the I around. I don't know if this makes sense at the moment. I don't want to get too deep into this.
In both letters.
No, you don't want them in both, because then they would just come out and cancel. So that wouldn't do anything for you. Yeah, okay. Maybe. Yes?
Do we have to get to that part for it to be?
No, in fact, like I said, we're not going to see a ton of complex numbers in here. We'll see it a few places, but not a ton. So I just want you to remember what they are. So this is going a little bit further than I meant to, but I saw a group do this, so I'm like, I wanted to bring it up. Okay. Let's do this. You guys are desperately tired of listening to me talk. So let's take like a 10-minute break, and then our next break will be at the end of class, so we'll just leave a little early. Is that all right? So come back at 5. If you have any questions, come up and see me. Otherwise, come back at 5.